Good afternoon. Is that coming through? Lucky I've got a big voice. Thanks, Erica. I wish I had all of that stack tracing capability in my distributed applications 15 years ago. We've really come a long way. Today, what I'm going to talk to you about is how migration to the cloud is changing. When I joined AWS 2.5 years ago, I joined at a pretty pivotal time. I joined at a time where I saw a lot of CIOs trying to be heroes in moving as much workload into the cloud as quickly as possible. We've got this syndrome here in in Australia, that CIOs want to be either the first or a fast follower in demonstrating how quickly they can adopt new technology. But once they've done it, they still need to prove to their CFOs, their risk officers, that they've done more than just move workloads. Now that we've seen the birds flying south, and we've got a lot of birds that are now flying very, very quickly towards the cloud, we've got a lot of skeptical people around, is lift and shift enough? And the answer is no, because it doesn't address everything. So let's take a look at just some of the reasons why companies move and what the common migration patterns are. So firstly, we see probably the most compelling one is data center exits. Have you noticed how much floor space or new data center capacity has been provisioned in this country over the last 5 years? Companies no longer want to be in the data center business. So they want to offload that to somebody. So with lease renewals or expanding workloads, it's a great opportunity. We see developers wanting to bring new features to their applications a lot quicker than they have ever done before. Or especially in what we've seen, particularly in the banks, where they need to run legacy systems but need to build a lot of innovation or digital services around that. Cost reduction goes without saying, but cost reduction in lift and shift only gets you so far. What we realized at AWS in the 12 or so years that we've been working with companies is that they go through these phases of adoption or maturity. Typically what we see is that one or two people inside the IT team or the developer team start spinning up projects. The cloud is fantastic for swiping your credit card, getting a VM up and running literally within a couple of minutes, moving a single workload, and voila, it works. It looks fantastic. Then what we typically see is that one person isn't enough. We see the rest of the team starting to adopt and experiment. Not only do they want to experiment, they want to learn best practices. So building a foundation of skill and capability is the next level of maturity. And then we typically see from one or two workloads to tens of workloads coming on at once. It starts to get visibility inside of the business. You know, new applications start to cost less, applications move fast, and then it starts getting visibility of CFOs, risk officers. And then what they want to do is they want to go all in on the cloud. And it's the most riskiest part when we see the hundreds of workloads coming in at that phase. Now, for those who don't have legacy, it's a wonderful path called cloud native. You get to bypass all of that risk. Get to bypass all of that pain. But that's just not a reality for most companies. Fact of the matter is they're not going to go refactor. Some can't even rehost. There's legacy applications that still run on legacy operating systems or libraries that just can't move that quickly or that easily. But this is where we started to see the change in behavior, saying, we're going to get there, but I want some of this cloud native stuff, right? Yes, it's great that I'm going to be able to take my data center away. It's great that I've moved from a heavy CapEx model to an OpEx model, but I'm not satisfying my developers because my developers want to still release faster. Or, as we're starting to scale, we're having performance issues. All those same performance issues, if I've just moved a VM from my on-premise environment to a similarly matched instance on the cloud, hasn't done anything for me. Or there's no automation. We're still having the same sorts of problems in the release cycle. Human hands always create problems. So this is what the cloud native people will say. We'll just take your application and turn it into microservices. Simple, right? Yeah, right. Where do you start? So let me just step through what we do see happening in the real world. So first, we do have to deal with the monolith. And we start by splitting it. We may start with very simple splits. We might take it from a stack perspective. We might split databases or data layers from application layers. Then we need to figure out how we make them communicate. And we replace the mechanisms for communication with something like a REST call using JSON or YAML. But fast binary encodings to be able to establish the communication between those parts. So we start to introduce this concept of services. And as we evolve through breaking down those monoliths into functional parts, and we re-establish those communication paths, we start to call them microservices. And this is a constant iteration. What starts to happen to these microservices is they breed. They breed very quickly because there's now an ability to create much smaller, compact business logic, release them much faster into an environment, add more functionality, or replace existing functionality. So that's pretty cool. But as they start to get bigger, what then starts to happen is, well, can we replace some of these components with managed services? And this is where AWS comes in, where we start to look at things like the API. If you want a durable API that does things like throttling and security built in, rather than building all those libraries yourself, you could use something like API Gateway. Or if you've got a highly distributed application where varying parts of that application have different performance cycles, you use queues. Or you have storage of large, rich media or objects. You'd use something like Amazon S3. So it becomes really easy to start replacing some of these services. So then the focus just becomes on the business logic, extracting the parts that are specific to your business. And your developers, this is what they do. Now, many organizations can stop there, but others choose to keep going further. They look inside those services and say, well, can we even get more granular? Can we even turn the functions inside that business logic into discrete atomic parcels of code? So we turn them into what we call Lambda functions or serverless functions. And the beauty of serverless functions is they become very repeatable, very reusable. Okay? And rather than having to compile legacy code, you can use polyglot programming, or you can use lots of different languages that best suit that particular interaction or the complexity of that business logic. So now you have a collection of functions that get run, and you only pay for them for the number of milliseconds that they're actually used. So how do I know which workloads to target? And how far do I actually go? Because I made that sound really easy. But the reality is this takes years. And in some cases, it's just not possible. And the reality is, in most organizations, is that there's legacy code where the original programmers aren't around anymore. So the first consideration is, starting with your monolith, is looking at its dependencies. Right? They may be dependent on particular platforms, particular libraries. Also, looking at where to start. Do you go for the jugular, for the most important piece, or the things that you can pick off really easily? Or things that can be replaced with newer services? When we get to the microservices part, we then need to start looking at scaling. And how does it scale? What are those atomic actions in that business interaction that needs the levels of scaling? So you're mixing those dependencies with the scale. Does it perform? Because the more I break it apart, the more latency I potentially have between those services. So am I still meeting the response times to the users? In some cases, may have broken things far too much. And functionally, does it also work? And when we start looking at functions as a service, we start taking considerations around how we actually optimize it. So if you remember that slide before, there's lots of different paths that your applications to take care of. Do I have circular dependencies in the way my business logic works? So looking at optimization and routing is also really important. So the good thing is there's lots of different patterns that you can actually start to break down your monolith. So for anyone who follows Martin Fowler from ThoughtWorks, he's done an awesome job at actually writing books about this. So I do encourage you to look at some of these patterns. So for example, the strangler pattern. The strangler pattern is not dangerous, I assure you. The strangler pattern starts to take the code and incrementally replace certain functions on the edges by still keeping that code intact. So what you're doing is incrementally deprecating old functions, still keeping them in place until you can actually test the new code that you're building around it. For others, a translator pattern, so building a translation layer in between. So building a new set of code between your REST-based API calls and your monolith on the other side. So let's talk about containers. Because when I was talking about containers 2 years ago to a lot of these enterprises saying, oh, no, we're not going to look at that. That's for new services. That's for cloud native. Well, it actually turns out that containers are fantastic for legacy applications. And 3 years ago, Amazon released the Amazon EC2 container service. Now, what containers was very good at was breaking down particular dependencies that go into the deployment of your application, running them independently of an operating system. And if you could get Docker up and running on your laptop, you could probably get it up and running in 20 minutes and get a .NET Core with an MVC application on top and a UI front end. I can probably do that in about 20 minutes. But I would hardly say that that's scalable. That's not production grade. So what we did was we built all the surrounding scaffolding. How do we scale these containers? How do we monitor these containers? How do we keep different versions of those dependencies in a container registry? So next I'm going to talk to you about 3 patterns that we continually see that work for these legacy applications. The first one is what we call vertical containerization. And this particularly works for applications where you've got strongly bounded dependencies between them. So you may have very particular or legacy runtimes or runtime libraries or particular database versions that need to work with that web application layer or that UI front end. The second pattern is a horizontal, where you've got an application that is able to scale. So it's typically a stateless application. And you can start picking those apart, so you can start taking, again, the web application layer away from the data layer, from the UI layer, and some of these actually have similar dependencies. This is really great for web application farms, especially J2EE applications that have been developed over the years and may run same versions of JDK libraries. And the final one is fragmented. This is really for distributed applications that all run the same types of runtimes. Now, you could run a complete mix of these in your environment. So let me actually step through some actual examples of what these would actually look like. So for those of you who are not familiar with AWS, I'll call out what some of these icons do. So this is containerizing a legacy ASP.NET application. So what I have here is I have my DNS service, okay? My DNS will talk to an application load balancer. Now, an application load balancer is different from an elastic load balancer. Application load balancer operates at the protocol level, so it's a level 7 or layer 7 application load balancer as opposed to a layer 2 load balancer, layer 3 load balancer. So if I have my URL hitting a particular endpoint that is going to my legacy MVC application, that will get routed to a container that contains 2 tasks. One of those is a SQL server, and another one is my ASP.NET. But I have another internal application that uses Microsoft Web Forms that uses a different version of the ASP or the .NET core, okay? And I may even be using different versions of SQL. But I can still package these up. And then what I do is, because those SQL Server environments have similar performance profiles, I can create my virtual machine farm based on instances that are optimized for that SQL Server. So for example, I may be having obviously some CPU-bound or some CPU-based instances like our C4s or C5s in that auto-scaling group, whereas what I'm looking for on the top is a UI interface which is fairly lightweight. I could get away with maybe our T series, which are burstable instances. Okay? Now, off to the side there, you'll see things like, well, one of the things that containers does suffer from is persistent storage. So if you have config files that need to be shared between these farms, we can actually use something like the Elastic File System to mount those in your Docker files to be able to pull down those config files, and all the logs can be stored in S3. Now, I'm going to get talking about what we do with logs in a moment. Let's look at another example. This is our horizontal example. So this is containerizing a 3-tier application. So you'll see here the same thing. We've got our DNS pointing to an application load balancer, and I may have direct data points with JDBC drivers going into my data access layer, or I may have some APIs sitting at my business logic layer, or I've got a UI front end. Again, it could be a Node application or JavaScript application sitting in the front. So what I've decided to do is independently create my Docker or my containers based on those 3-tier apps. Now, one of the clear distinctions, one of the benefits of this is a great pattern for reducing things like software licensing costs. Because what we saw a lot of, even in the VM world, is that we would buy a new web application server for every single one of our applications. So what we can actually do is consolidate our web application layer. Again, whether you're using a commercial web application like BA WebLogic or WebSphere, you can actually reduce your dependency on those. Okay? But what we are looking for here is that you are running similar versions of runtime environments in those different layers. Okay? Now, another major difference is I can group all of my EC2 instances in one auto-scaling group. All right, let's look at a distributed application. Now, when we look at distributed applications, we can start picking off much more fine-grained things. So, for example, I can take something like identity management or authorization, for example. I can create a separate custom authorizer, or I can more modularize some of my business logic. So those layers there are a lot more finer-grained in what they actually do. So this is obviously for a completely stateless, very loosely coupled and low dependency type of application. So here again, I've got one endpoint and my URL is pointing to different parts of my application. I've got a home page, a catalog, and a checkout. Now, what is great about this type of pattern is that I'm using, again, a single farm of, or a single fleet of different EC2 instances. And what my EC2 container service is doing is mapping that task based on the metrics that we collect. As you can see up at the top there, our CloudWatch service is actually monitoring how many actual calls are being made to that business function. And that's how we would actually scale those EC2 instances. So again, it actually even further compresses the amount of virtual machines that you'll actually need. So there are three common patterns that we see. And again, we've been doing this for a while. And as great as EC2 is, what we heard customers saying is that that's really cool that I can now use all these very fine-grained metrics that you give me in CloudWatch, but I still need to manage servers. So what we did last year is that we announced AWS Fargate. AWS Fargate takes away your decision of having to scale those VMs. So you literally just give us the Docker files, we monitor all of the different performance attributes, and AWS will actually provision all the underlying EC2 instances. They will auto-scale them, as well as scale them up and down based on that demand. So if we see, for example, in that previous, that we have a low number of catalog searches, we actually scale that farm down. You no longer even have to make decisions about what instance sizes. That's something that AWS will do. Now, another thing that we have also seen is the rise of Kubernetes. I think everywhere we go, we seem to talk about Kubernetes. But what Kubernetes has done is it's taken Docker, which is very good at obviously describing all the different dependencies, and it's built an enterprise-grade orchestration layer, audit layer, scaling layer. So we also introduced last year the EKS, the EC2 container service, or Kubernetes service. And I can tell you there's a lot of excitement about this. We've gotten a lot of customers asking when it's going to be in Sydney. And I can tell you it is just a couple of months away now, so which is great news. But we also have a very rich portfolio if you are ready to go over to serverless. Why customers build this on AWS is because we have all of these underlying management services which are consistent. So whether you're building identity management and authorization around these services, or whether it's around logging, it's using a common service across all of those services, regardless of the mix that you actually use. All right, but as cool as these products are, AWS doesn't do everything. And what we hear is like, well, where do I start? You talked about those different dependencies that I need to understand. How do I do that? Well, this is where New Relic comes in. And with the ability to be able to actually understand all of the dependencies in an application trail, you can very, very quickly see all of the different application connections, dependencies, databases, internal and external to an application. So it's great at being able to map that very, very quickly. Now, deciding migration order is also another big decision. May not be so difficult when you've got 10 applications, but when you're moving 500, 700, we have customers with 1,000 applications. That becomes a very manual and menial task to do. And planning sprints becomes a nightmare without this sort of information. So again, this is where what New Relic does in being able to take all those dependencies, looking at those across the entire landscape, helps you understand, which hosts could be targeted for migration first. All right, so once I'm actually migrated onto these services, how does monitoring change? Because before, in my environment, I would be looking at things like CPU and memory at the VM layer. Well, now I'm running containers. I'm much more fine-grained. So this is another area in which New Relic is really optimized for. So being able to look at things like response times, being able to look at read and write latencies. Remember, as you break apart your monolith, you've got more communications or subsystem communication going on. Being able to understand those in the context of the business function becomes really, really important. And this is what you can actually see for the container service. So the level of instrumentation and the ability to see that down into some very fine-grained business functions is an incredible, powerful way. So on one side, you're going to have a lot more microservices in your environment, a lot more loose coupling. But with this sort of intelligence and this sort of visibility, it does make the experience a lot easier. So just to wrap up, don't automatically lift and shift your applications anymore. Okay? Nobody wants to be a hero and say how fast I got into the cloud. What you really want to be able to say is that you got in there well. Understand dependencies, and those dependencies need to be looked at in these different dimensions: scale, performance, and also cost. Use containers over virtual machines. Again, if you look at the Kubernetes ecosystem, if you look at these cloud-managed services like EKS or like Fargate, it is enterprise-grade. And the automation of being able to scale these services up and down means that it takes a lot of what you would have to build around VMs away. Leverage those proven migration patterns. So whether you are prepared to go and refactor some code or at least go down to a library level, definitely leverage the patterns that have been tried and true. And it's really important to invest in a new set of tooling, because I can guarantee you that your old tools won't work anymore. So hopefully that gives you some ideas. Hopefully it gives you a path to start exploring. Again, something to keep an eye out for. We've been drafting quite a few blogs recently around some specific patterns and specific applications. So if you are interested, I do encourage you to go to blogs.aws.amazon.com. There's a complete section there on containers. We've just written some really cool stuff around Microsoft containers that you can start trying in your own environments. So thanks very much.